This is the second Glowscript video tutorial for Physics 151. Today we will make objects move and work towards simulating the asteroid collision with the Earth. Then in class we'll follow up with that program to save the Earth. I've already logged in. You should log in if you haven't. We will go through most of the program, show you a few new features, and then you will add a couple of things to the program for class on Wednesday. New trinket, Glowscript, Python. Click on Untitled, give it a name. Asteroid hit Earth. Save early and often. Hey, go back over here, click on line number 2, and I hit enter. So as before, we're going to have objects, spheres, except this time the spheres will be the Earth and the asteroid. So let's start by putting in the Earth. I'll put RE for radius of Earth, sphere. This is the position vector of the Earth, and we'll use the one that we used in class, vector. 1.2 times 10 to the 10, and in Glowscript you can shortcut that by doing an e for exponent. So 1.2 times 10 to the 10 is the initial x position of the Earth, and it's on the y-axis, so the y and z coordinates are 0, 0. Next line will actually create the Earth sphere at that position. Give it the name Earth equals sphere. Properties are the position of the center of the sphere, pose, equals, and I want that to equal the initial position of the Earth, RE, comma. I'm going to make the Earth blue in honor of all the water. Color, and it sets the color property as color.blue, comma. And I should give the Earth sphere a radius. This will not be the real radius of the Earth. This is chosen to make it visible on the screen. So I picked radius equals 6e, 6 times 10 to the 8. Up here on line 3, I'll click at the end, do a couple spaces, hashtag. That will create a comment, and the comment will be that distances are in meters, units of meters. That's to remind me. Hit enter. Now, another property that the Earth had that we used in class was the Earth was moving. It had a velocity. One of the nice things about Glowscript is if you create an object, a sphere, in this case the sphere we named Earth, you can give other properties to that object that are not normally inherent properties of a sphere. So I can give the Earth the property of a velocity. And here's how you can do that. I type Earth, the name of the object, a dot to get to a particular property, and I'm going to call this property for velocity VEL, and equals. The Earth will now have a property that we're calling VEL for velocity. Again, it's a vector, vec, and in class we use the Earth velocity as a minus sign since it was headed in the negative x direction towards the origin. 3 times 10 to the 4, so that was the speed, and in this case it's just moving the x direction, so 0, 0 for the y and z components. Let's do a quick hashtag here, units of meters per second. And there we've created the Earth. In the same way, we can also create the asteroid. I'll go ahead and set that up. Again, the asteroid has a position vector. I'm typing the position vector separately to make it easier to change later if we want to. So R, capital A, equals, position is a vector, vec, and in class we put it on the y-axis. So the x-coordinate is 0. The y-coordinate we picked was 1 times 10 to the 10 meters. 1 e 10, and then the z component is 0. Go to the end, and we can create the asteroid. Equals sphere position pose equals RA, color equals color dot yellow, and we should give it a radius. I'll make it a little smaller than the Earth sphere. Radius equals 2 times 10 to the 8th. Again, that's not the real radius of the asteroid. And I'll let you, as part of your homework, give that asteroid object its velocity. Save often, and let's just run it, make sure everything's okay so far. There's the Earth, there's the asteroid. So far, nothing is moving. So we need to make things move. Now in class we did the calculation all in one go. We set the final position of the asteroid and the final position of the Earth to be the same and calculated the time it took to do that. That works okay if you have a constant velocity and don't have anything that's affecting that constant velocity. But we will want to be able to allow the velocities to change later so that doing the calculation all at once will not necessarily work out well. So the alternative is to do the calculations in tiny little steps. So for instance, you can say we're going to do the calculation and see where, say, the Earth is at a time. Click back over here at a time that I'll call dt for small time, delta time, a little bit of time, equals, say, 4,000. And again, units of seconds. And if you were going to use the position update, it would look like this. First I'm going to make a little bit of gap so that we see the Earth at the first time and then see where it is a little later, and this happens slowly enough that we can actually watch it happening. So I'll tell the, I have to click over here so I get the solid cursor. So I'll tell the computer to wait, let's say half a second, just so we can see what's going on. Then using the position update formula, which we've worked with in class, we're going to take the position of the Earth, earth.pause, and set that number equal to whatever it was to start with, earth.pause, and add to it the displacement of the Earth, disp E for Earth. So mathematically this looks like nonsense, but remember, with a computer on the left, that's the name of some memory location. So we're taking that memory location and putting into it whatever was already there and adding something to it. So we're changing the position of the Earth. And if I run this, it's going to say, oh, you have not defined disp E, and I haven't. So before I do that, I have to put the cursor at the beginning of line 14, hit enter, make a new line, and I have to define the displacement. The displacement of the Earth is equal to the Earth velocity times the little bit of time that passes. Okay, so I've taken the position update equation and in a sense broken up into two parts so we can see the displacement calculation and then see how that gets added to change the position. We'll save it, run it. If you look real close, you saw the Earth move. Run it again. So if you haven't typed this in at this point, you might want to type it in. Please give it a new name. You can use my name, but just please give it a name you haven't used before. And then run it so you can see the Earth move just a little bit. And you can pause to do that and then come back when you're ready. Okay, so 4,000 seconds have passed. If you remember from class, we have to go more like 400,000 seconds. So let's keep going. We need to do this again. So we could just copy what we already did. Select it, Control C, move the cursor down to line 17, paste it, save, run it again. Let's go ahead and put the sleep statement in so it goes slowly enough to see. Sleep 0.5. Run it. So you see it move the 2 times. And we could keep going. We can copy all this, put the cursor here, hit enter a couple times, paste it, and run it again, and now we should see 3 iterations of time. 1, 2, 3. Oh boy, oh boy. Only 97 to go. This would take a while. Again, the reason we're doing it in small time steps is because when we get to the point of where the velocities are changing, we need to be able to do this as the velocity is changing, so we won't necessarily have the velocity the same all the time. So these Earth dot vels may be different at these 3 different times. But this is getting a little bit repetitive and will take a long time. So this is not the best way to do it. I'll get rid of that sleep statement altogether and get rid of all these extra times we did it. We want the computer to do these 2 calculations on lines 12 and 13 automatically a whole bunch of times until the total amount of time has passed. Okay, so I'm going to put the cursor on line 11 and hit enter so we can start entering the commands that will tell the computer, go ahead and do this calculation a whole bunch of times. There are different ways of doing that. The one that's appropriate for what we're doing would be while. In other words, we want the computer to do this while time has not reached the total time we want to reach. We know the total time we want to reach. We calculated that in class, so we'll go ahead and use that. Since that's an important number, we'll go ahead and give it a name. I'll go up to make a new line 10, type big T. This will be the total time equals, and the total time we had in class was a 4 with 5 zeros after it. I'll just do a hashtag here, total time. Okay, and I'm doing that so down here I don't have to type a whole bunch of numbers, and it makes it easier to change the numbers later if I want to. So while time is less than the total time, I want the computer to keep doing the calculation. So that means I also need a name for time. t equals 0. So that creates something called t, sets it to 0. And this is time. Units of seconds again. Okay, so while time, little t, is less than or equal to the total time, big T, I want the computer to do the calculations. At time big T, it should reach the proper place. So when you're telling the computer to do this, while little t is less than or equal to big T, then at the end of that line, you need to put a colon. This is one way Glowscript keeps track of which calculations it's going to do over and over. The other way is the lines that it's doing over and over, this position update, those lines are indented, so I'll indent them by 2 spaces. So in Glowscript, this is how we do calculations over and over, what's called a loop, or several iterations of a calculation. We have a while, a condition, it will keep going while that condition is true, a colon, so Glowscript can keep track of things, and then the things that are going on over and over and over are indented. Now we have to do a couple of other things. But first, let's go ahead and save this. Let's run it to make sure everything's okay. And it goes loading, 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 and it's just going to keep doing that. The reason is, and this is a peculiarity of Glowscript, is Glowscript tries to figure out ahead of time if you have a situation where the program is going to run on forever and ever and ever. And that's what this program is going to do, because we never changed time. So time is 0, and 0 is always less than 400,000. So Glowscript's way of dealing with this is to simply dig in its heels and not run the program. So, and we can do this while Glowscript is spinning its wheels. Put the cursor at the end of line 16, hit enter, and we need to make time increase. Take time, set it equal to whatever the time was before, plus the little bit of time that we're doing for each pass through the calculations. Save, and run it again. Okay, so Glowscript's gotten a little cranky about what I did to it before. So I've saved it. It's getting really, really cranky. I'm going to come out of it and simply go back in again. And run it again. And, okay, it happened really, really quickly because I didn't do anything to slow it down. When you do have a loop like this, especially one with animation, one thing you need to do, put the cursor at the end of the while statement right after the colon, hit enter, and we need to tell it how fast to run, what's called rate. Okay, before we had it running every half second, so the rate would have been 2. It would have been going through the calculations twice a second. That's a little on the slow side. The human eye is kind of programmed for 30 per second, so I'll do a rate 30. Save and run, and that slows it down so we can actually watch things happening. And in addition to controlling how quickly the computer goes through the program, this also helps avoid those issues of it freaking out when there's an infinite loop. Okay, so we have the Earth. The Earth is moving. We haven't made the asteroid move yet. You'll take care of that for homework. To tell whether we have reached the condition of the asteroid hitting the Earth. We need another calculation though. Inside the loop again, so you'll notice that when I put the cursor at the end, it automatically indents it when I hit enter. We need to calculate where the asteroid is relative to the Earth. I'll call that rel, asteroid Earth, because we need some way of telling through numbers how far the asteroid is from the Earth. So I will set that equal to the position of the asteroid. Asteroid.pose minus Earth dot. And remember, this is a way of getting a vector that points from one object, the Earth, to the second object, the asteroid. And I want to be able to print this out so I can have a record of how things are going instead of just relying on visual. So print, it's a function, open parentheses, and I want to know time, comma, t, comma, specify the units of seconds, move over, comma, and distance, move over, comma, and the distance is the magnitude or the size of this rel AE vector I've created. So mag rel AE. And comma, and let's specify those units again of meters. Save it and run it. Same display before, except now it is displaying time and distance. So you will have homework, of course. The homework will be on Moodle, but it will include setting this up, revising this, so that it also makes the asteroid move in the right way according to what we did in class. You will need to give the asteroid a velocity, and you will need to set up the position update for the asteroid within this loop here. Then you will see if it gives results that match what we did in class. What we did in class was a fairly exact calculation. If what your program gives you doesn't exactly match what's in class, then you should say something about it. I'll give you a hint. It'll be fairly close, but you may need to think about, well, is it a little different for a reason? See you in class.